thank you everyone for joining us today, wherever you may be. Today we're going to talk about network security, or more specifically, how to create better network visibility while maximizing your security resilience. And joining me today, I have Phil Trainer from Ixia, who's the Senior Product Manager of Applications and Security. Regardless of whether you're from an enterprise or service provider, whether you're in networking teams or in IT, fundamentally, what we're seeing in security today is that it is a top-of-mind problem. And yet, what I see personally is that many enterprises and service providers struggle to manage all the different security appliances that they have in their network. And there's a number of streams, the amount of traffic multiply. It's almost impossible to get a handle on all the different threats coming to your network. And what I see very often is a lot of enterprises and service providers just, blindly spend, tens of thousands or hundreds of thousands or even millions of dollars just upgrading to the latest security appliances, 10 gig, 40 gig, 100 gig. And yet they don't have additional visibility, yet they don't know if they're more secure. And so fundamentally the question is, how do you get a handle on your security defenses, and how do you get better visibility and management, and how do you use the appliances that you have in a more optimized manner? And so today, Phil from Ixia is going to talk to us and explain, what are these current security tool deployments that he sees out there. How can we improve those things? And as part of the process, Phil's going to talk about what a bypass switch is, what an NPB or a network packet broker is, and what's the role that an NPB can play. And overall, he's going to talk about some of Ixia's next-gen, cool products that can reduce the risk and optimize the security appliances that you've already paid good money for. So with that, I'll turn it over to Phil. Phil, go ahead.
Awesome. Thanks a lot, Roy. And guys, can everyone hear me all right? Let me just
You sound great.
Start.
Yep.
Awesome. Thank you so much. And everyone, thank you so much for taking some time on your Friday to take a look at some of the concepts that Roy outlined earlier. Let's see. Punch up the slides. There we go. And let's advance. Okay, I'm really not going to go into the metrics of how many new attacks out there and what an attack costs a person. I mean, we all work in the security industry, and we're all very aware of the cost of doing this. It's why we all have jobs, and it's why our customers are so engaged with us to find out what the latest solutions are. So I'm going to jump right into some of the newer techniques that we've established have been incredibly fruitful when not only giving resilience into your network, but really allowing the security solutions you're deploying to work in the most effective manner. All right, so right off the bat, traffic rates are increasing. We have more users on our systems, more devices, and in order to give inline security, it's necessary to implement larger and larger infrastructures. Everyone's kind of deploying what we almost call inside the industry a security sandwich. There are more and more steps to get from point A to point B, more and more solutions. Whenever one of these inline solutions fails, then we have created essentially a problem. Either they're going to fail closed and become a roadblock in our network, or they're going to fail open and not be performing their core task. And this is something that people struggle with. And there's really not a great solution to this a couple of years ago. So this is one of the things that at Ixia we really kind of spearheaded a mechanism in which to make this not an issue anymore. Also, another problem comes up is your inline solutions need maintenance all the time. They get new firmware patches, they get new security updates, or they have to have work done on them for whatever reason. Now they're out of line in your network as well. This becomes a cabling issue, an uptime issue, and a connectivity issue. Managing this in an appropriate way, especially in a larger infrastructure for a company like a Visa or a Facebook or a Google, this is a real problem. And this is really the problem that I'm going to talk about solving. Especially true when you have different maps through your servers to get in there. All of a sudden now the complexity goes up. Something goes down, and now you're worrying which rack is up, is high availability working, what's the traffic load on one end versus the other. There's a lot of questions, and really what it comes down to, a lot of risk. Then you couple onto that the fact that we're putting multiple devices in line. We're trying to have high availability built in, we're having scale built in, and we're trying to use our tools. And these tools, as Roy pointed out, are very expensive. In order to use them efficiently and get your max value out of them, you really have to do things intelligently. Talk a little bit more about some of the current problems. Between the downtime, the upgrade disruptions, and all these other scaling problems, if you can find a way to very simplistically solve this problem, then to make our lives a lot easier. Okay, let's talk about the risk of downtime also. There's one device goes out, I mentioned earlier, then we have the problem that we're either failing open or failing close. And this is a real issue that we face. Same thing when we're doing tool failures. Our various tools are doing things like deep packet inspection, they're doing DDoS prevention, they're doing WAN acceleration. There's so many things going on. Our solution to do this is implement a product that we call our bypass switches. Now, a bypass switch is a physical piece of hardware, and it operates at nanosecond speed through heartbeats to ensure that your solution is up. If it's not up, it takes it out of your network within nanoseconds. This is a very elegant mechanism for doing this because it ensures that whether you're upgrading a piece of equipment or it just failed for whatever reason, it'll never be that question mark in your network. And that's something that we've encouraged a lot of people to do, and our customers who have deployed it in this manner essentially get fewer phone calls at 2 o'clock in the morning and have less downtime. I was working with a online auctioning company a few years ago, and they estimated to me that every minute of downtime was $1 million. So essentially, we are eliminating risk. It's really what we're doing here. The live heartbeats are really what makes this a critical and reliable scenario. The live heartbeats on the application layer ensure that what we're doing stays up and works, even if we think it's partially down. A ping is really not a great example of a system being up, because if they're running an application layer process, ICMP can be working while the underlying process is no longer up. Same thing is true with upgrade and maintenance. Patches come out constantly, and sometimes these patches require reboots or long upload procedures, and generally they're not available in your network. Doing this is crucial. With a bypass switch, you can take it out of your network very cleanly while keeping the management up, access your system, make the changes you need to, then put it back in your network. Now let's talk about utilization. This is a scenario that bypass switches doesn't solve. All it really does is ensures that you have that availability of that solution no matter what, and it also helps you manage that availability. But capacity utilization, it really has no play in. And that's why we've added a second layer that we call network packet brokers. Essentially, a network packet broker is a aware inline piece of equipment that allows you to perform a number of actions on your security tools. Those actions include aggregation and tool load balancing, as well as heartbeats. The intelligent load balancing allows you to selectively route different traffic to different tools, and this is a very critical thing. Let's say, for example, that you want all traffic from one zone going through a sandbox, but you don't have the capacity for all of your traffic to do this. You can selectively pick traffic through filter rules from one zone to another. Furthermore, you can state, I want to have everything go through the next-gen firewall, and I want all of my inline users' traffic to go through my data loss prevention device. Being able to do this intelligently, built in with a bypass switch, not only guarantees constant uptime, but that intelligent routing and management of all network traffic. If one piece of equipment falls out of your network, the network packet broker, much like the bypass switch, will recognize this with intelligent heartbeats and take it out of your network. This management mechanism is absolutely infallible in terms of being able to selectively take things out, or without any action of the user, take things out that fail. And that's a very effective thing. Same thing as upgrades. This is where it gets cool. And this is something that I've done a lot of work with a lot of different companies in their network, and this is really value of the solution. Let's say that I want to scale capacity with this. Great. With a high-density network packet broker appliance or blade, you're able to put in multiple solutions. Think about that for a second. Anyone here who has worked extensively with high-end next-generation firewalls or sandboxes knows that your 10 gig next-generation application-aware, content-aware, potentially sandboxing next-generation firewall does not operate at line rates. It absolutely doesn't. In order to build in the processes that you want to, let's say that, for example, you have a network link that's typically doing 100 gig. You're going to need to have probably double that capacity in order to effectively utilize things without maxing out the CPU on all of your devices. With a network packet broker, you have the ability to plug everything in to that one NPB. That one NPB will intelligently load balance this over all of your devices. This ensures that if one of those load balance devices goes out, we'll take it out of the network. But during bursting scenarios or peak scenarios, we're making sure that we get the most money out of your system. And this is crucial because each one of these firewalls can cost upwards of $100,000. The maintenance on them is very high. If you're able to deploy them in a mechanism where you can save yourself even 10 or 15% on your devices, then the NPV is not only paid for itself, but also it's made your life a lot more simple by looking at one pane of glass in order to draw out your entire network. And let's say that you want to increase the capacity. Let's say that you're getting more and more network traffic. You realize you need to add more capacity. Fantastic. Plug in your new solution into the NPB, redraw your rules in the NPB GUI, and all of a sudden now we are now load balancing under an additional device. And Roy really touched upon something that's very important about this. Let's say, for example, that you have a network that's operating at or near 10 gig, and now you need to expand. Do you throw away your 10 gig firewall and then get a larger capacity one, a 40 gig firewall, or do you just buy another 10 gig firewall and load balance those two devices? Keep your existing investments. The equipment you have, as long as the firmware is GA and the rule set is current, is absolutely a functional piece of equipment. And let's say, for example, you don't want to do a even load balance. Let's say you want 1/3 of the traffic on one device and 2/3 on the other because you bought a next version of the previous piece of equipment. No problem. This is saving you a lot of money being able to do this because you're able to keep all your old infrastructure, and also it saves you man hours or woman hours. I'm not going to be gender specific here, but you're able to say, you know what, I'm going to draw on one pane of glass the traffic route that everything's going to go through, and I'm going to have some pretty complex rules, and I'm not looking at a script. I'm not trying to figure out what someone did in some code. I'm looking at a very clean GUI. I'm drawing lines from ports to tools. I'm selecting a new tool port pair, and I'm saying, okay, my NGFW goes in this, and everything goes through that. After it goes through that, a selective group going to just the executive branch, or just the salespeople, or just the engineers, or just whatever group you select, also goes through our sandbox. It's very clean, very easy. It's essentially saving you time and saving you money. And obviously, we've eliminated all the single points of failure. The high availability is also a really important thing. I'm based in Asia, and a lot of the companies here not only want high availability, they want high availability. They want to ensure that uptime is going to be there no matter what takes place. Creating these high availability scenarios are also equally easy. There is complete cleanliness in creating a configuration where there is redundancy built in, and should various aspects fall out of the network, capacity is built into it that allows the reconfigured on-the-fly in nanoseconds load balancing to have the resources redistributed in high availability. It's a very clean mechanism, and really what it comes down to is your risk management officer, who's working closely with your CISO and your NOC and SOC team, will be able to build into his risk model this high availability model. Doing so, they'll have that confidence that your HA plan is going to be executed without downtime. It'll be executed within nanoseconds. One thing I really want to emphasize in all these solutions is one thing Exia does very, very well is we are a hardware company. We make great software to run our hardware, but all this is built on purpose-built ASICs. And by doing that, we're able to operate on that level. Furthermore, Ixia is also a test company. We make a large array of network traffic generators, and this is beautiful for creating an inline device like this. We take our various testing solutions, and we test these things at line rate 64-byte packets. We test them at having a huge number of connections and an immense state table. We test the SSL capabilities of them. We test every aspect, and also we do negative testing. We fuzz these devices. We put rough traffic through it. We put this thing through the exact same QA cycle that we implore our customers who are building these security tools I'm talking about to use our test tools in order to ascertain the risk of their devices. It's a really nice amalgamation having a company that creates the mechanism in which to verify the resiliency of an inline device, also make an inline device that is designed to maximize the uptime, high availability, and also value of inline security tools. Kind of a very symbiotic scenario. Another concept, it doesn't just have to be in-band. We do a lot of out-of-band stuff also. If you want to have an out-of-band sandbox, we can absolutely connect those as well. In fact, if you want to have any kind of taps for, let's say, long-term storage, or in general, just in order to keep records, logs, or traffic. For example, let's say that you're a bank, and your bank needs to have a copy of all traffic sent for posterity. No problem. Out-of-band tapping is something that our solutions work with very, very well, as well as out-of-box sandboxing, or any kind of other solution that requires to have your traffic made a copy of on the fly and sent to a device for analysis. At a very high level, I mean, essentially, with these solutions, the downtime risk is the biggest value. We're giving the HA configuration and the ability to pull something out of your network within nanoseconds. And this is really maximizing the value of your solutions by not turning them into roadblocks inside your network and ensuring in your risk model that they're going to be up all the time. And if they're not up, we're going to handle that. Secondly, efficiency. Back to what Roy talked about. If you're going to be intelligently load balancing all your tools with the exact mix of traffic that you want to send them and the exact ratios, then you can maximize the value of all of your solutions. The next-gen firewall you bought in 2014, as long as the GA version is still current and the firmware updates are still there and the signature updates are still there, there's no reason why you can't use that in your network with the 2017 models. There's no reason why you can't just load balance a lower amount of traffic over that device than your other ones, or make it part of your HA model, or do whatever you and your team really feels is the best solution for you. Just knowing that you can plug everything into this one network packet broker and then draw in our GUI intelligent lines to say, these ports go to these tools, this is the traffic that goes to the tools, and this is my HA scenario, this is my risk management scenario, and this is my heartbeat failure scenario. Lastly, I want to talk a little bit about how we can improve various security monitoring scenarios, not only with other solutions, but also we have our own inline solution that works with it. I'm sorry, it's out of band. This right here is, pressing pause, play. Is it playing for me? Well, what I wanted to show was a concept we called our ATI processor. This is the application and threat intelligence processor that's built into the solution. You don't need to turn it on. It's completely out of band. But one thing that Ixia does very well is we understand threats and we understand various attacks. It's really the basis of our entire apps and security model, and that's the area in which I'm a product manager. Our ATI processor is built into the advanced feature module of a lot of our cards. A lot of our test solutions have application and threat awareness. They're able to create the most current attacks. Also, we do maintain a global array of honeypots. This really filters into what our motto is of complete visibility of your network. If you want to turn on the advanced feature module inside your network packet broker, you can see lots of great things, like you can see throughput, but also geolocation of traffic. The scenario I'm looking at right here is something that's very interesting. You can put rules in this as well, and you can see things like, is data being moved from my network from the US to China, from Australia to the UK, or how about North Korea? This is a scenario that came up a little while ago that showed the exfiltration of data from the Sony attack. During the attack, for the most part, the traffic was being moved out through proxies, but for a very brief time, those proxies were not used, and North Korea was the destination of that network traffic. And this is the Sony scenario that we came up with. What's really cool about this is it's built into your visibility solution. So not only do you have visibility into the tools you're deploying and also have bypass built in and load balancing built in, you can also use the advanced feature module in our network packet broker in order to visualize data the way that we, a visibility company, think people should be looking at. Not only do we do app analysis, geolocation, as well as dynamic discovery of new applications, we also talk about what browsers are people using. What operating systems are people using? What applications are they using? Let's say you had a very strict process of only allowing Windows 10 machines or MacBooks on a network or whatever process. If you want to have that specific of a policy in your network, we will do that kind of discovery for you. We'll tell you where your users are talking to. It's a really great companion to being able to intelligently load balance, have high availability, bypass, and all the other great network packet broker features that are built into our entire network visibility family of solutions. That's essentially really all I have for this. I'd like to open up now to any questions anybody might have concerning either the network packet brokering, bypass, or even our advanced feature module, the App Threat Intelligence Engine.
Excellent. Well, thank you, Phil. And at this point in time, I would like to ask the audience to go ahead and ask their questions. Definitely, go ahead and do that, and we'll go ahead and answer those questions. And if for some reason we don't get to them today, we will make sure that we make those answers available in a Q&A post when the on-demand assets are available on the SDX Central website. So let's see, we have a couple of questions that I see, so maybe let's just go to those that are coming in. So I think the question here is, so if you put a network packet broker in line with all the traffic that's going through the security appliance, how are you able to guarantee that there is no packet loss when that happens?
It's an awesome question. Pretty much what everyone really comes down to is how can I take your word for it? And there are several ways that we can ensure this. I mean, right off the bat, we're using FPGAs and ASICs in order to perform these actions. So we're not doing it in software, we're doing it in hardware, which is a much more resilient mechanism of doing it. Secondly, as I talked about before, we are a tool company. We are a test company, and we make solutions that will measure up to 20 nanosecond latency what the time is for a packet to traverse a network. We'll tell you exactly what the packet loss rate is, the latency is, the jitter is. Every aspect of that traffic, we will tell you definitively, and this is built into our QA process. And our QA process is such that we do not release a GA version of these visibility solutions unless they have passed a very high standard of testing that we as a testing company think that everyone should be able to really meet that level without any packet loss with minimal latency before being deployed to production network.
Got it, excellent. And I think that's definitely a good point. I guess I was just reminded that Ixia manufactures the very test equipment that is used to test the highest end switches and routers from basically all the leading vendors in the world effectively. And so that's, you actually set the standard for ensuring that there is no packet loss in the very high-end switches that people pay a lot of money for. So given that, I think there's probably a lot of credibility in the test that you run on your own NPBs to ensure that there is no loss. So that's actually a very good point. Let's see, next question here. For the Ixia network visibility solutions that you have, right? Who do you, you talk about a couple of use cases, a couple of examples in the data center and the like. This one is, what's the ideal customer, right? Who is this a good fit for?
Oh, another good question. Really, I've deployed this in everything from governments to social media companies to carriers. I mean, essentially anyone who's running a network that is doing anything complex. I really can't list out our customers right now, but literally it's governments, it's carriers, enterprises, it's a higher institution, educational, not just universities, but also remote universities. It's just about anyone who wants to intelligently deploy any kind of network solution, everything from firewalls, switches, routers. If you're going to be managing devices, especially inline devices, then you're an ideal customer.
Got it. And in general, I mean, this is not, I guess this is my own follow-on question. This is not something that only the largest of the large, with humongous data centers can benefit from, right? It seems like, just being able to take services offline, online, upgrade, downgrade, spread load across, different versions of your security appliances. It seems like to me that there is a wider audience for this than the sort of, very large corporations with, humongous data centers.
Oh, you're absolutely correct. We have a solution called Vision One, and the Vision One, you don't have to activate all the ports at once. It's meant to be modular. If you really only want to deploy, let's say, 24 ports, then you can absolutely do that. And even for a small organization, they'll use 24 ports very rapidly. I mean, once they start going through various devices, it's very easy to use that. So you can absolutely get into it at a very low-end cost. That being said, you can also be China Mobile or AT&T and use us and have capacity in the dozens of terabits of traffic per second. So we could even do as low as a couple of gigs of traffic per second, all the way to dozens of terabits. So you're right. I mean, we don't have a one-size-fits-all. We have a large array of solutions that really fit an organization based off the capacity needs.
Got it. Excellent. And then this is a very common question. Everyone asks this of just about everything out there. Is there a cloud version of these solutions? Whether it makes sense or not, I'm not sure. But is there a cloud version? Could ask the question.
Oh, that's definitely a topic for another lecture. But Ixia just launched a whole range of solutions that we call Cloud Lens, and that involves virtual taps and a whole array of virtualized products for managing devices and also for gaining visibility to devices in the cloud. I almost don't want to delve into this because it'd be a whole other lecture, but Cloud Lens is something that we've very recently came out with and we're talking about right now a lot, and is really catering to the trend that we see based off of cloud. I was talking to my colleagues about what's going on in RSA right now, and it seems to me that the cloud providers and the companies deploying solutions in the cloud are really getting the most interest. And we're very much in lockstep with this so that we're able to help people more intelligently gain visibility into the cloud structure. And that is with our Cloud Lens solution.
Got it. Excellent. Thank you. Well, sounds like another topic for another day, but let's see. So at this point, I'd like to encourage the attendees to go ahead and submit questions. And again, if you don't get to it, or if it comes to you later on, you're welcome to reach out to us on SDX Central. And if you just email support at sdxcentral.com and say, hey, I had a question for this webinar, we'll definitely direct that to Ixia and get you an answer as well. So it doesn't, if you come back and say, well, yeah, I meant to ask a question, but the webinar's over, go ahead and submit the question anyway. You can reach out to us, and we'll make sure that Ixia gets the question. So at this point in time, let's see, I think, for now, it looks like we've answered all the audience questions. I'd like to thank Phil for his time here, and audience, your time with us on today's webinar. And if you enjoyed today's webinar, I'd like to encourage you to join us on 2 upcoming webinars, mostly around the next generation data center networking. One is by Big Switch on February the 22nd, talking about, next generation networking and fabrics and the like. That's 10 a.m. Pacific time on February the 22nd. And then the other one is why SDN ecosystems matter in the data center from Huawei on February the 24th at 10 a.m. So if you enjoyed today's webinar, I encourage you to go ahead and sign up for those. And then with that, I'd like to wrap up today's webinar by once again thanking Phil Trainer from Ixia for joining us and sharing his thoughts on network packet brokers and improving security, visibility, and resiliency. Thank you, Phil.
No, thank you. Thanks for having me on.